Hello there! We are back with another informative video. Today we are going to uncover the reality behind the lab-grown and natural diamond. If this type of video interests you, you could support by subscribing to the channel, comment, like, and share. Now, let us dive into the reality. First, let us discuss about lab-grown diamond. Laboratory-grown, LGD, also called lab-grown diamond, laboratory-created, man-made, artisan-created, artificial, synthetic, or cultured diamond is diamond that is produced in a controlled technological process. Unlike diamond simulants, synthetic diamonds are composed of the same material as naturally formed diamonds, pure carbon crystallized in an isotropic three-dimensional form, and share identical chemical and physical properties. As of 2023, the heaviest synthetic diamond ever made weighs 30.18 carats, 6.0 grams, and the heaviest natural diamond ever found weighs 3,167 carats, 630.4 grams. Lab-grown diamonds of various colors grown by the high-pressure and temperature technique. Numerous claims of diamond synthesis were reported between 1879 and 1928. Most of these attempts were carefully analyzed, but none was confirmed. In the 1940s, systematic research of diamond creation began in the United States, Sweden, and the Soviet Union, which culminated in the first reproducible synthesis in 1953. Further research activity yielded the discoveries of high-pressure, high-temperature diamond, HPHT, and CVD diamond, named for their production method, high-pressure, high-temperature, and chemical vapor deposition, respectively. These two processes still dominate synthetic diamond production. A third method in which nanometer-sized diamond grains are created in a detonation of carbon-containing explosives, known as detonation synthesis, entered the market in the late 1990s. A fourth method, treating graphite with high-power ultrasound, has been demonstrated in the laboratory, but as of 2008 had no commercial application. Both CVD and HPHT diamonds can be cut into gems, and various colors can be produced: clear white, yellow, brown, blue, green, and orange. The advent of synthetic gems on the market created major concerns in the diamond trading business, as a result of which special spectroscopic devices and techniques have been developed to distinguish synthetic and natural diamonds. The first known diamond synthesis was achieved on February 16, 1953, in Stockholm by ASEA, Allmänna Svenska Elektriska Aktiebolaget, Sweden's major electrical equipment manufacturing company. Starting in 1942, ASEA employed a team of 5 scientists and engineers as part of a top-secret diamond-making project code-named Quintus. The team used a bulky split-sphere apparatus designed by Baltzar von Platen and Anders Kempe. Pressure was maintained within the device at an estimated 8.4 gigapascals, 1,220,000 pounds per square inch, and a temperature of 2,400 degrees Celsius, 4,350 degrees Fahrenheit, for an hour. A few small diamonds were produced, but not of gem quality or size. There are several methods used to produce synthetic diamonds. The original method uses high pressure and high temperature and is still widely used because of its relatively low cost. The process involves large presses that can weigh hundreds of tons to produce a pressure of 5 gigapascals at 1,500 degrees Celsius. The second method, using chemical vapor deposition, CVD, creates a carbon plasma over a substrate onto which the carbon atoms deposit to form diamond. Other methods include explosive formation and sonication of graphite solutions. In the HPHT method, there are 3 main press designs used to supply the pressure and temperature necessary to produce synthetic diamond: the belt press, the cubic press, and the split-sphere BARS press. Diamond seeds are placed at the bottom of the press. The internal part of the press is heated above 1,400 degrees Celsius and melts the solvent metal. The molten metal dissolves the high-purity carbon source, which is then transported to the small diamond seeds and precipitates, forming a large synthetic diamond. The original GE invention by Tracy Hall uses the belt press, wherein the upper and lower anvils supply the pressure load to a cylindrical inner cell. This internal pressure is confined radially by a belt of pre-stressed steel bands. The second type of press design is the cubic press. A cubic press has 6 anvils, which provide pressure simultaneously onto all faces of a cube-shaped volume. The bar's apparatus is claimed to be the most compact, efficient, and economical of all the diamond-producing presses. On the other hand comes the natural diamond. A natural diamond is formed when carbon atoms crystallize under extreme pressure and temperature, typically occurring deep within the Earth's mantle, where conditions are right for carbon to bond into a diamond structure. This process usually takes billions of years and happens primarily within volcanic pipes, called kimberlites, which can rapidly bring the diamonds closer to the Earth's surface through explosive eruptions. Don't forget to like and subscribe for more.